Good morning, students. So we'll move on to the architecture of IoT. Right. So in today's lecture, we'll be discussing two different architectures of IoT, which we are considering it as a basic architecture. Right. So this is not the final architecture over which our entire syllabus is dependent on. Okay. But by using these two different architectures, so which is visible in your screen, that one M2M IoT architecture and World Forum. Okay, one more architecture we are discussing in today's session. Okay, so based on this, we'll be going for a simple architecture for our IoT. Fine. So in one M2M and World Forum, there also we are facing some difficulties over there. So based on those difficulties, we'll be designing a one common platform or one common architecture for IoT network exactly. Okay. So what is the full form of this one M2M exactly? Okay. So this is one machine-to-machine IoT architecture. Right. So this is a machine-to-machine communication kind of the architecture. So why we are mentioning this is the only one architecture which is providing machine-to-machine communication for IoT architecture. Fine. So we'll go through. The one M2M architecture divides IoT functions into three major domains. Fine. So the complete IoT network or complete IoT application, whatever we are having, so that will be categorized into three different sections exactly. The first one we are calling it as an application layer. Second one we are calling it as a service layer, and third one we will be calling it as a network layer. Fine. Okay. So application layer means, remember, we are discussing about the IoT architecture. Okay. So when we are discussing about IoT architecture, we will be dependent on different certain kind of applications. Okay. See, if you want to achieve a IoT based architecture for a house, okay, then we need to manage the CC camera. Okay, automation should be available. Then for monitoring and controlling the power or electricity or else the lighting system, whatever we have, for that we should have. Then for utility we need to have. Okay, so certain different types of automation we may be expecting for a house. Okay, so when you are considering it for particular house, okay, there may be a different application we need to include. So these different applications are handled by this application layer. Yeah. Okay. See, the logic of IoT is the network layer. Okay, whatever you can observe in this, like three different parts we are having. Network layer, the hardware will be deployed. Okay, and the communication network, whatever we are expecting, that will be enabled. Using that communication layer or using that network layer, we will be communicating to the service layer. So in this service layer, we'll be utilizing some protocols, okay, for security basis and all. Finally, data will be processed, and finally, data will be submitted to application layer exactly. So here, models of data, okay, what we are expecting, okay, that will be prepared. Okay, finally, we are going to come to a conclusion based on certain aspects. Okay, then sometimes we may be grabbing the information. That's it. Sometimes after grabbing the information, we need to change something. Okay, change in the network layer. That should be performed. So this is how the IoT architecture usually works exactly. Okay, so network layer grab the information, it will be transferred to the service layer, processing will be done. Finally, it will be sent to the application layer. Then the decision will be taken by the application layer. So this is the basic logic, okay, of any IoT architecture exactly. Okay, while this architecture may seem simple and somewhat generic at first glance, okay, it is very rich and promotes interoperability too. Okay, so here, as I mentioned, we need to deal with different kind of applications over here in one kind of architecture. So interoperability is very essential. Remember this. Okay, there should be some communication between different applications over here. Okay, remember. So we should enable. So while designing the IoT architecture, we should enable this type of interoperability. Okay, fine. Later. So this is what the one M2M architecture, what you can observe. Okay, so these are the three different layers. So this is what the application layer. So this is what the service layer, and this is what the network layer exactly. So we'll begin with this network layer. What is this network layer? Applications talk to the APIs to communicate to sensors. Okay. So these are all what the end devices we call it as. Okay. So this is what the connectivity what we are having. Okay. So these are the, see, you can observe, these are the Like horizontal, whatever lines we are having, those are the services we are available with, and the vertical, whatever we are having, they are the application exactly. So, so this is what the network, okay, the cloud kind, whatever we are observing, that is what the network, okay, and these are the connectivity exactly. So network layer, okay, it is pure dealing with what the edge devices or the sensors, whatever we are utilizing, right? So that will be dealt by the network layer, okay. So in the service layer, one M2M includes a common service horizontal framework, okay, supporting RESTful APIs. Okay, so these are the services what we are providing. Just observe common service layers, okay, like common uh, technologies and protocols, so communication technologies and protocols, then communication networks, then communication devices and hardwares. Okay, so which are essential to generate any particular network. Okay, so that is responsible of what service layer exactly. So here we are having a protocols, here we are having a devices, hardwares, and etc. etc. Okay, such so that will be handled by the service layer. Okay. Then when it comes for the application layer, see here we are having something called a smart energy asset tracking and fleet management regarding the vehicles and all. Okay, so these are the different applications, okay, like using which we can get service from the architecture example, okay, like automotive applications we are having, home application we are having, energy application we are having. So these are the three different applications which I want to run over my IoT network, okay. So these are the different applications exactly. Okay, so now what this application is going to do is, okay, so the end users or the end devices, whatever we are having, which is read by the network layer, so their responsibility is to collect the information. Okay, then this information which we are collecting from these end devices will be coming to service layer. So here we'll be processing them. Okay, the data processing and what many things will be done. Okay, based on the protocols and all. So finally it will be submitted to application layer exactly. So here, based on the received information, what they are going to do is they will take some decision exactly. Okay, sometimes, okay, that will be intimated to the user. Okay, here the user interface. Okay, this is what the hardware end or else the sensors. Okay, like real-time environment it is. Okay, from here we are grabbing the information, service will be provided, and finally communicated to the user exactly. So sometimes it will be just intimated to the user, like so this is what the temperature is about. But sometimes we need to take some action. Certain action should be taken exactly. Okay, so how it will be taken and all that we will be discussing in module number 2 and all. We are using something called as actuator. Okay, based on which we'll be taking certain action in the real-time environment. Okay, that will be communicated back to the end users. Okay, and later from end users will be providing some changes. Okay, so that will be communicated back to the sensors and all. Okay, so this is how the one M2M architecture used to work. So here we got some explanation regarding application layer. The one M2M architecture gives major attention to connectivity between devices and their application. Okay, so the end devices like sensors and all whatever we are having, okay, so we need to provide a proper, reliable, and secure kind of communication between the devices and the application exactly. So we'll see that how we can do that. Okay, so this domain includes the application layer protocol and attempts to standardize API, okay, definitions for interaction with business intelligence system. Okay, so uh, like application layer, okay, like standardized kind of API or else the data format, whatever we are trying to get. Okay, so according to that, the data format should be exactly. Okay, like what the business intelligence system is, what those applications, whatever we discussed, like home application, automation, or else many like three different applications we observe, right? On what format they are expecting the data, in that format it should be available. Okay, so that is the responsibility of what application layer exactly. Then later, applications tends to be industry specific and have their own sets of data models. Okay, and thus they are shown as vertical entities. Okay, so here the application layer, one more responsibility is we are dealing with like three different applications, right? Okay, so three different applications we are dealing with. So each and every application is expecting certain data models in that, right? Okay, so according to that, we should be able to provide the information. Remember? So this is the responsibility of what application layer exactly. Okay, so later service layer. So this layer is shown as a horizontal framework, okay, across the vertical industry applications. At this layer, horizontal model includes the physical network, okay, that the IoT application runs on, okay, the underlying management protocols and the hardwares. Okay, so the service layer, as name only indicates, is provides a service related to the network. Okay, so here we'll be using the hardware, we'll be using the network, we'll be using the protocols and all. Okay, based on which we'll be generating a secure kind of a network, okay, using which the devices can interact with the application layer. Remember, then the network layer, when it comes for the network layer, so the communication domain for the IoT device at the endpoint, okay, it includes the devices themselves and the communication network that links them. So this is the base of network layer exactly. We will be involving the connectivity between the network. Okay, see the service layer. We need to provide a connectivity between the service layer and the network layer. One thing, and later we need to handle the endpoint devices exactly. Remember, this communication infrastructure includes wireless mesh technology. So this is regarding the topology. What kind of topology we need to say? Okay, such as IEEE 802.15.4. Okay, and wireless point to multi-point systems such as IEEE 801.11ah. Okay, so in module number 2 and module number 3, we'll be discussing about such type of IEEE standards, okay, which are useful for connecting our devices for the network itself. Okay, so these are the different topology we may be using for our requirement. Okay, so how we are expecting the network should be, okay, like that we'll be utilizing, whether it is point to quality point or sometimes it will be a mesh technology. Okay, so in many cases, the smart device communicate with each other. See, the devices simply communicate through your field area network. Okay, remember, whenever we are deploying any kind of a sensor, okay, it is having its range exactly, right? It will be having its own range. Then later, the neighbor sensor, it is also having a range exactly. When these range are intersecting in one location, feel that, okay, it is a circle, okay. One sensor is having a range of a circle, second sensor is also having a range of circle. If there is an intersection point between these two ranges, okay, then there is a possibility of communication between like first sensor with the second sensor. This should not happen, okay. That we are calling it as what? Field area network. Okay, we are considering it as what? Field area network. Using field area network, the communication between sensor to sensor should not be available exactly. Okay, what we need to do, we need to provide a gateway. One sensor, if it want to communicate with other, okay, directly it should not communicate. Remember, it should be communicated to gateway exactly. Gateway to application, application to second sensor. Okay, there should be a proper way. Okay, so we are using a demarcation point between the devices and the network domain. Remember, okay. So such type of communication should not be allowed exactly. So this is what some brief introduction about what is one M2M architecture. Okay. So next we'll go for one more standard architecture, that is the IoT World Forum or IoT WF, we call it as standardized architecture. Okay, fine. We'll see this. What is the difference or how advanced kind of architecture we will be discussing compared to the one M2M. See, first one M2M was, later IoT World Forum is. Okay, in 2014, the IoT World Forum Architecture Committee, okay, it was led by Cisco, IBM, and Dr. Automation, okay, and others, few others, published a 7-layer IoT architecture reference model. Okay, how we are having OSI model, right? Okay, application layer, presentation layer, then session layer, network layer, transport layer, okay, data link layer, and physical layer, 7 different layers, whatever we are having. Such type of layer we are also having in IoT architecture example. So what is the purpose of those 7 layers exactly? See, each and every level is having its own contribution exactly. Is it right? Like physical layer is dealing with the devices, then data link layer for the security, then network layer for providing the IP and presentation layer, data formats and all. It's a step. Okay. Then finally it will be submitted to application layer, right? Okay. Likewise, here also in previous one M2M only 3 layers we have. Okay. The load for those 3 layers will be more. Okay, so what we do, we are going to divide it in 7 different layers exactly. Okay, then the hectic or the burden over the layer will be less, and we can achieve the efficiency, and we can also achieve the accuracy more. Okay, so like that, we'll see. While various IoT reference model exists, okay, one put forth by the IoT World Forum, okay, offers a clean, simplified perspective on IoT and includes edge computing, data storage, and access. Okay, so a lot of functionalities can be achieved or can be accessed by using this World Forum. We'll see that what are those different layers and all. Each of 7 layers is broken down into specific function, as I mentioned. Remember, and the security covers the entire model. Okay, security is the main aspect of it. Okay, so next. So these are the 7 different layers. Okay, so in exam, no need to write this type of graphical kind of a picture. Okay, you can just go for this type. Okay, like the layers 1, 2, 3, 4, 5, 6, 7. So the bottom layer, okay, as usual, physical devices and controllers. Physical devices and controllers exactly. Okay, so what are these things exactly? See, are the things in IoT. Okay, that is nothing but the devices. Okay, which is exposed for the physical world. Okay, we are calling it as what? We will be calling it as things exactly. What are those? See here, sensors, devices, machines, intelligent edge nodes of all types exactly. So these type of devices if we are having, so that will be handled by the physical devices and controller layer exactly. Okay. Then later, see devices we have, so we should provide some connectivity over there, right? For establishing that connectivity network, we are having a second layer, we are calling it as connectivity layer. Okay, so the job of this is what? Communication and processing unit. So whatever the information we are getting, that should be collected by this network and also it should be processed, remember. Then later, edge computing we are having. What is this edge computing? See, I'll explain it. Okay, see, instead of sending the information, okay, from here to direct application layer or else the processing layer, which is at the top, okay, some sort of processing should be done in this particular level itself. Okay, then the rest of the computation we can send it for the higher layer. Otherwise, if only the higher layer is responsible for analysis or analytics or whatever the computation is about, then we'll be generating a bottleneck kind of a situation. So that should be avoided. Okay. So here in edge computing, the main procedure is what? Data element analysis and transformation. What is this transformation? So the received information will be in different format exactly. Is it right? Okay. So that should be converted in such a format that we should save the information in this layer exactly. What is that layer? Data accumulation. Data accumulation. Okay. So in data accumulation, the main job is what? Storage. Okay. After storing the information, we need to go for data abstraction. That is what? Aggregation and access. Okay. See, from different sources, we'll be receiving the information and it will be stored exactly. Right. Then later, it is not compulsory like the related information should be available in one drive itself. It may be available in different drives of the storage location. So we need to grab them. Okay, we need to collect them. Later we need to access. Okay, or it should be provided for the access exactly. So that is the job of what? Data accumulation, aggregation and access. Okay, so later that should be provided for application layer where reporting, then analytics, then control. Okay, so over which we will take some action. Finally, it will be communicated to the collaboration and processes. So this collaboration means, okay, you can observe, just observe it, observe this diagram. Okay, center, we are calling it as. So here we are having some monitoring system, video system, okay, communication kind, sharing kind, okay, connectivity. Many applications are available exactly. So between this, there should be a collaboration. Means interoperability must be available. Remember this. Okay, interoperability should be available between these different applications exactly. That's why we are calling this layer as what? Collaboration and processes. Okay, so the main function will be involving people and business processes. Okay, so this is what the World Forum 7 different layers. Okay, now we'll deal with them individually. Okay, so here in general data travel up the stack. Okay, from the edges. Okay, originated from the edges. It's not visible exactly for me because the software toolbar is instructing me to read that. Okay, I think it is from like in general the data travel up the stack. Okay, originating from the edge. Okay, and goes northbound to the center. Okay, using this reference model, we are able to achieve the following. So these are the 4 different things we are going to achieve. Okay, decompose the IoT problem into smaller parts, then split the problem into a smaller parts, identify different technologies at each layer and how they relate to one another. Okay, so that should be identified, like how they are interrelated, that should be identified. Have a process of defining interfaces that leads to interoperability. Okay, so such type of interoperability exists, then we need to define some interfaces. Okay, we need to define some interfaces where we are having the interoperability. Then later, define a tied security model that is enforced at the transition point between the levels. Okay, so different layers we are having, is it right? Okay, so between this layer, there will be a transition, right? Okay, like transition from one layer to another layer. There we need to provide different tiered kind of security model exactly. Okay, so there may be a chance like between the layers we'll be having some connectivity, right? Okay, there may be a chance of malfunctioning the information exactly. So such things should not happen exactly. Okay, so the physical device and control layer we are having. Okay, so this layer is home of the devices. Okay, in the Internet of Things includes the various endpoint devices and sensors that send and receive information. Okay, pure devices it is. Okay, pure devices. The size of these things can range from almost microscopic sensor to a giant machine in a factory. Okay, so the range of the sensor may vary exactly. Their primary function is generate data and being capable to be queried and or controlled over a network. Okay, the main job of this physical device is what? They need to collect the information, then later, if application layer want to control them, okay, or want to take some action, okay, then they should be controlled over a network. Okay, so these are the two different jobs because feel that we have a room, okay, we have an AC, right? If the temperature level, okay, goes above uh, 25 degree or else 30, okay, then automatically AC should turn on. Okay, later when if it reduces below 80, then AC should be turned off exactly. Okay, by based on sensor we can observe the temperature, right? Okay, but for turning on and turning off the AC, we need actuators. Okay, so that is what which is explosive for the physical world. Okay, we'll see that later how it can be done and all. Okay, so such type of controlled over network function should be available for physical devices exactly. Then later connectivity layer. So here we have the focus is on connectivity. The most important function of this IoT layer is the reliable and timely transmission of data. Okay, like real-time information will be grabbing. Is it right? We have a main difference between IT and IoT, right? IT and IoT architecture. Main difference is what? Scheduled based data transmission will be available in case of IT network architecture, but here real time data transmission should be available. So time to time we need to transfer the information. And one more thing is what? Reliable information should be transferred. Means security is the main aspect over here. So this includes transmission between layer 1 device and the network, between the network and the information processing that occurs at layer 3 exactly. So this is the mediator between layer 3 and layer 1. Okay, so it should receive the content from the layer 1 and it should be processed and it should be transferred to the layer 3 exactly. So few functionalities it has been mentioned over here: communication between layer 1 devices, reliable delivery of information across the network, switching and routing, then translation between protocols, then network level security. So these are the main function which is computed by your connectivity layer, that is layer number 3. Then layer number, sorry, layer number 2. Layer number 3, edge computing layer. Okay, this is important, edge computing. Okay, so at this layer, the emphasis is on data reduction and converting, and converting network data flow into information that is ready for storage and processing by higher layer exactly. So after this edge computing layer, we are having a data accumulator exactly, right? Layer number 4 exactly means the storage. Okay, so the information which is there in the network, okay, which may not be suitable for the storage exactly. That should be processed, okay. That should be analyzed, okay. Few information will be unnecessary, okay. So what we need to do, we need to reduce the data, okay. See, one sensor per day, if it is generating like 100 MB of information, all 100 MB is not useful for us, okay. For storage purpose, remember, for real time it may be useful, but for the storage purpose, it may not be useful exactly. So we need to analyze it properly and we need to reduce the data rate. Remember, okay. Fine. One of the basic principle of this reference model is that information processing is initiated as early. Okay, like you may ask like why we need to be dependent on data analytics or data analysis in this space exactly. Okay, so as I mentioned, if we are continuously transferring the bulk of information to the application layer, okay, there will be a chances of generating a bottleneck condition exactly. The data available for processing will be more, but the application layer cannot handle it properly. Okay, may not handle it properly. So what we can do is, okay, whenever data is generated in the edge level, if we are trying to process them, okay, then after processing 50%, it will be transferred to the application layer. Then the 50% of the job will be done by application layer exactly. It will reduce the hectic process for application layer. That is what the main intention. Another important function that occurs at layer 3 is the evaluation of data to see if it can be filtered or aggregated before being sent for the higher layer. Okay, data aggregation is very important. Okay, like average, okay, data will be considered. Okay, rest of all will be neglected exactly. So this also allows for data to be reformatted or decoded. Okay, making additional process by other system easy. Okay, so reformatting data is very essential because from here it will be free from the network. Okay, so it is just like a network layer. Up to here we can consider as a network layer, later service layer, then application layer. Okay, so data should be represented in proper format. Okay, a critical function is assessing the data to see if predefined threshold are crossed. Okay, and any action or alert need to be sent. Okay, so sometimes what the data flooding may be more. Okay, so there will be a limit for data generation, right? Okay, if there is a condition like if you are violating the predefined threshold, okay, then there should be an alert indication like yes, this is going to happen. Okay, then action should be taken properly. Okay, so these are what the edge computing related. The function will be what edge like layer number 3. That is regarding the edge. So the main function is evaluate and reformat data from processing at higher level, filter data to reduce traffic at higher level processing, and access data for alerting, okay, notification and other actions. Okay, so this is about layer number 3. Okay, so those were the 3 main layer. Okay, then later layer number 4, data accumulation. Okay, this is for the storage. Okay, this is for storage exactly, data accumulation. Fine. It should be in a proper format. Okay, we need to convert it into a proper format so that it can be stored properly exactly. Okay, so that is what the job of data accumulator. Then data abstraction layer. This is like we need to collect the data from the different locations of the data storage. Okay, and it should be available for providing it for the application layer exactly. Okay, so we don't have a much discussion about these 4, 5, 6, and 7 layer. Okay, main thing is bottom 3 exactly. Then later layer number 6, application layer, enterprise data using software applications. Okay, application may monitor, control, and provide reports based on the analysis of the data. So this is what the job of layer number 6 exactly. Then layer number 7, okay, layer number 7, collaboration and process layer. Okay, so we should have a interoperability facility over here. We consume and share the application information. In collaboration and communication, IoT information often requires multiple steps, and it is what makes IoT useful. Okay, so these are the different layers of word forum. So here the very important thing is what the layer number 1, 2, and 3. Okay, the main functionality will be done by those 3 layers. Layer number 4, it is for storage. Okay, so it will be available in different locations. That should be aggregated. Okay, so that is for data abstraction layer. And fine, obviously, like we'll be going for some kind of filtering the information from this level exactly. Layer number 5. Layer number 6 will be application layer. Okay, interprets data usage. Like based on the software, will be taking some action over here. Okay, and later it will be separated for layer number 7. Okay, where all the functionalities are residing, and we need to provide a interoperability between this also. Yeah. Okay. So this is it for now, students. So we'll read with the original architecture of the IoT in next section exactly. Okay. Thank you, students.